Hello, and welcome to another episode on the Total Space Network. I'm Mikko, the host of Deep Dive Fridays. Today, we are taking a look into what the Mars helicopter Ingenuity has accomplished so far. The Perseverance rover was launched last summer and it arrived to Mars this February. While the rover itself is more or less in the beginning of its journey, it has already created some oxygen from the atmosphere with the MOXIE experiment and taken some amazing shots of its surroundings and its history-making passenger, the Ingenuity Mars helicopter. Ingenuity has been in the making for quite a while and it was actually in danger of not getting a ride to Mars, but it did catch the ride after all. The helicopter itself is minuscule compared to the Perseverance rover, weighing at 1.8 kilograms on Earth or just 0.67 kilograms on Mars. It's 49 centimeters in height, with a rotor system span of 1.2 meters. The big counter-rotating plates rated at 2400 rotations per minute are needed with the thin atmosphere of Mars, which is under 1% of the atmosphere on Earth. And on the contrary to modern movies, you would not really feel the sandstorms on Mars, even if you were able to go out without a spacesuit. The helicopter has its own solar panels to recharge on its own and not be dependent on Percy to charge. It also has wireless communication with the rover and has computers, navigation sensors, and 2 cameras from which we have actually seen pictures. For example, it spotted the rover already, however small it is on the picture. Speaking of the computers on the helicopter, technology has come far enough for computers to be fast enough for flying on another planetary body. The processor on helicopter is Snapdragon 801, something you could just actually find on your cell phone. By the way, this processor is massively more powerful than what the rover uses for its operation, as it has to have radiation-hardened hardware to work for years or even decades on the planet. So the Ingenuity's central processing unit is not hardened and so far has not had any problems with radiation even during the trip in space. The helicopter also runs a Linux-based operating system. The communications to the rover are actually using a fairly new technology, Zigbee. Does that sound familiar to you? If you have smart lights at home, they could be using Zigbee as the wireless communication protocol. Now that we have gone over the basics of the helicopter itself, let's see why it was built in the first place. Ingenuity is purely a technology demonstration mission and doesn't do science like the rover, but it is pioneering the path for future operations on Mars. Helicopters could scout for rovers, survey the terrain from air, or even be a science mission in itself. It is far easier to cover ground by flying than driving on wheels. Let's take a look at the key objectives NASA has set for this mission. First one is to prove powered flight in the thin atmosphere of Mars. The red planet has lower gravity, about 1/3 of that of Earth, but its atmosphere is just 1% as thick, making it much harder to generate lift. Second is to demonstrate miniaturized flying technology that requires shrinking down onboard computers, electronics, and other parts so that the helicopter is light enough to take off. Third one is to operate autonomously. Ingenuity will use solar power to charge its batteries and rely on internal heaters to maintain operational temperatures during the cold Martian nights. After receiving commands from Earth relayed through the rover, each test flight is performed without real-time input from Mars helicopter mission controllers. Now, let's see what the helicopter has accomplished so far. After finding a good spot to take off from and deploying to the ground, it took some time for the team to complete the preparations for the flight, but then on 19th April 2021, history was made. First powered flight on another planet. Ingenuity didn't really seem to do much on the first flight. The blades turned on and helicopter lifted off and reached a peak altitude of 3 meters, hovering there for some time while rotating clockwise before touching down softly on surface again. And yeah, pretty much all the milestones completed on the first flight. Next up, expanding the envelope step by step. Second flight happened just 3 days after, on 22nd of April. It was already a bit more complex with the following objectives. Start horizontal motion with maximum airspeed of 0.5 meters per second after takeoff up to a height of 16 feet or 4.9 meters. Stop horizontal motion. Take snapshots using horizon-facing color camera. Rotating counterclockwise in place. Land in the same place of takeoff after moving. And counterbalance lateral wind pull. Once again, all executed perfectly. Then on to the third flight, which was already much more difficult. Lifting off on 25th of April with the following objectives. Start horizontal motion with maximum airspeed 2 meters per second instead of 0.5 meters per second, while maintaining almost the same height to which it was flown on second flight. Land in same place of takeoff after taking a round trip ranging up to 164 feet or 50 meters north of takeoff site. And again, completed successfully. And the fourth flight is making it even harder. Fourth flight was attempted on 29th of April, but for some reason the helicopter didn't take off. But then a day later it tried again and accomplished the following objectives. Start horizontal motion with max airspeed 3.5 meters per second instead of earlier 2 meters per second, while maintaining almost the same height to which it was flown on the second flight. Land in the same place of takeoff after taking a round trip up to 436 feet or 133 meters south of takeoff site. Take black and white images for every 4 feet or 1.2 meters while traveling between 84 and 133 meters and taking color images while hovering at the point on 133 meters before returning to the takeoff site to create a 3D map. And finally, to be the first interplanetary spacecraft whose sound was heard and recorded by another interplanetary spacecraft, Perseverance rover. Once again, perfect. And the sound, just take a listen. And we can even compare the audio to the recordings on Earth. Hopefully we will hear more audio from Mars. By the way, there was also some Martian wind sound in the recording. Then, on 7th of May 2021, Ingenuity did its fifth flight. Lifting off from the Wright brothers field, the helicopter flew to another location completing these objectives. First flight without return to the initial takeoff site, landing on a new site. Rise up to 10 meters above the new landing site. End the technology demonstration phase. And you guessed it. There will be a sixth flight coming sooner or later. Not much information on it yet, but it will begin a new operation demonstration phase after technology demonstration phase. There will be one-way flights, more precision maneuvering, greater use of its aerial observation capabilities, and more risk overall. It is expected to fly every 2 to 3 weeks until the end of August. Ingenuity is dependent of communications with the Perseverance, so this means it cannot go too far from the rover. So at the end of its mission, it will most likely be limited to serving the road for Percy, as long as it survives all the tests before that. I would be just as happy to hear about a test where NASA's JPL found the limits of the helicopter rather than hear dust storm blocked its solar panels. Couple of fun facts about Ingenuity. It carries a piece of fabric from the wing of the 1903 Wright Flyer, the Wright brothers' airplane, which was humanity's first controlled powered heavier-than-air flight on Earth. The initial takeoff and landing area for Ingenuity is named Wright Brothers Field as a tribute. Before Ingenuity achieved the first heavier-than-air powered flight on another planet, the first flight on a planet beyond Earth was unpowered balloon flight on Venus by the Soviet Vega 1 spacecraft in 1985. So, what do you think about the Ingenuity mission? How will the mission end? Tell me in the comments. And while at it, do subscribe and follow us. As well as like the video so we know to continue producing content. We also have other shows on our channel. After this video I would suggest checking out Becoming Multiplanetary livestream where we went into the details of Perseverance mission. Or maybe the Space Update interview about the James Webb Space Telescope with NASA. And there's lots of interesting interviews coming up soon. And if you really like what we do, head over to patreon.com/totalspace or find the PayPal link in the description to support us. And as always, I'd like to thank our amazing supporters. Ryan McDonald, Michael Mars, Anthony Mann, Warhawk Me, Adrian Moisa, The Angry Astronaut, Howard Walker, Sammy Oscuro, What About It, Jisuan and Sebastian from To the Future, Gia Pagliari, Susie R, and Marco Makuc. Thank you very much. And thanks for watching. I've been Mikko, the host of Deep Dive Fridays. See you in the next episode. Bye bye.